Did you know that Voyager 1 is currently traveling at 38,000 miles per hour through interstellar space, yet it would still take over 73,000 years to reach the nearest star? This incredible spacecraft has been humanity's most distant messenger for decades, sending back data from the edge of our solar system, where no human-made object has ever ventured before. But here's the mind-blowing part. It just detected something moving out there that's completely rewriting the rules of space exploration. Do you know what could possibly be lurking in the cosmic void that caught Voyager's attention? The mysterious detection. What if I told you that humanity's most distant messenger just stumbled upon something that's rewriting the rules of space exploration? Voyager's instruments suddenly lit up like a Christmas tree when they detected an anomalous signal showing something in motion far beyond our solar system's boundaries. This wasn't your typical space rock drifting aimlessly through the void. The object wasn't following any predictable orbital pattern that planets are known for, and its movement seemed almost deliberately erratic. Scientists initially dismissed it as a potential glitch in the decades-old equipment, but when multiple readings kept confirming the same impossible data, they realized something extraordinary was actually out there. The object appeared to be moving in ways that completely defied conventional astronomical expectations, accelerating and decelerating at seemingly random intervals, as if it possessed some form of intelligence or control system. What made this discovery even more mind-bending was that the movement patterns were so unusual that astronomers had to throw out their existing tracking models and create entirely new ones just to follow its trajectory through the cosmic darkness. The readings suggested this mysterious entity was operating under principles that our current understanding of physics couldn't easily explain, leaving the scientific community both thrilled and deeply unsettled by the implications of what Voyager had accidentally discovered in the furthest reaches of known space. Beyond planetary motion. You know what separates a wandering space rock from something that might actually be intelligent? The way it moves? This wasn't your typical celestial body behavior that astronomers study in textbooks. We're talking about something that completely broke the fundamental rules of how objects are supposed to move through space. While planets follow those predictable elliptical orbits around stars that we've mapped for centuries, this mysterious object was dancing to its own cosmic rhythm, moving in patterns that seemed to mock our understanding of orbital mechanics. The really spine-chilling part? It appeared to accelerate and decelerate at what seemed like random intervals, almost as if something was making conscious decisions about where to go next. Scientists watching the data streams felt like they were observing a chess player making calculated moves, rather than a lifeless chunk of matter drifting through the void. The movement patterns were so fundamentally different from anything in our astronomical databases that researchers had to abandon decades of established tracking protocols and develop completely new mathematical models just to predict where this thing might go next. What kept everyone awake at night was the unsettling realization that this object seemed to possess some form of propulsion or guidance system that operated independently of any known gravitational influences, suggesting either revolutionary physics at work or something far more extraordinary than anyone was prepared to admit publicly. Instrument readings gone wild. When a machine built in the 1970s starts detecting signals that don't exist in any modern database, you know something's seriously wrong. Voyager's magnetometer and plasma wave instruments began registering readings that sent shock waves through mission control, displaying data patterns that didn't match a single entry in their comprehensive astronomical databases. The object appeared to be generating its own electromagnetic field, which is incredibly rare for natural space objects and typically only seen in active stars or massive planetary bodies with molten cores. Even more bizarre, the readings suggested this mysterious entity might be rotating or tumbling in a highly complex pattern that created interference signatures unlike anything scientists had previously encountered from asteroids, comets, or typical space debris. The electromagnetic emissions were so unusual that they seemed to pulse in rhythmic intervals, almost like a heartbeat echoing through the vacuum of space. What made the situation even more unsettling was that these readings were coming from instruments that had been functioning flawlessly for decades, suddenly encountering phenomena that their creators never anticipated when designing the detection systems back on Earth. The data streams showed energy signatures that fluctuated in ways that suggested either some form of internal power source or an interaction with unknown cosmic forces that current physics couldn't adequately explain. mission scientists found themselves staring at computer screens, displaying information that challenged everything they thought they knew about how objects behave in the cold emptiness of interstellar space, leaving them questioning whether they were witnessing a natural phenomenon or something far more extraordinary. The rogue object theory. So, what happens when scientists discover something that's, too small to be a planet but way too active to be just dead rock? Well, at first scientists thought maybe this could be a rogue planet, one of those lonely worlds that gets ejected from its original solar system and ends up wandering through the infinite darkness of interstellar space, sort of like a cosmic exile. These planetary outcasts are known to drift aimlessly through the void after getting gravitationally kicked out of their home systems by larger planets or big stellar events. But the size readings from Voyager's instruments just didn't match up with what you'd expect from a typical rogue planet. And even more puzzling, rogue planets don't usually move with such unpredictable and honestly almost purposeful patterns. They tend to follow predictable trajectories influenced by the gravitational pull of nearby massive objects. But this mysterious entity seemed too small to qualify as a planet, yet it was far too large and energetically active to be classified as your typical space debris or asteroid material floating through the cosmic wasteland. What really threw researchers off was the object's apparent ability to change direction and speed without any obvious external gravitational influences acting on it. That kind of behavior totally contradicted everything scientists thought they knew about how rogue planets should behave out in the emptiness between star systems. The data pointed to something that existed in this strange middle ground between planetary and non-planetary classifications, leaving the scientific community with, way more questions than answers about its true nature and origin. This discovery really forced astronomers to rethink their basic understanding of what makes a planetary body, and whether there might be entirely new categories of cosmic objects drifting through space that just don't fit into our current classification systems. Artificial origin speculation. The moment scientists started whispering about artificial intelligence in deep space, everything changed. Here's where the discovery really took a turn, and made even the most skeptical researchers pause and rethink everything they thought they knew about our cosmic neighborhood. Some scientists began seriously wondering if this mysterious object could actually be artificial in origin, a possibility that sent ripples of both excitement and, honestly, a bit of terror through the astronomical community. The object's highly unusual movement patterns, those distinctive electromagnetic signatures, and its apparent ability to change direction without any obvious external forces, led to these hushed conversations about possible extraterrestrial technology drifting out there in the void. Now, while most established researchers stayed publicly skeptical and didn't want to jump to such extraordinary conclusions, the data piling up was compelling enough that even the most conservative astronomers couldn't completely dismiss the possibility of an artificial probe or spacecraft from another civilization. What made this theory so unsettling was that the object seemed to actually show behaviors that matched up with some kind of guidance system or onboard intelligence, responding to unknown stimuli in ways that natural space objects just don't. The electromagnetic pulses appeared almost like communication attempts or maybe diagnostic signals, suggesting internal systems that could be actively monitoring or scanning the surrounding space environment. All this speculation opened up some mind-bending questions about whether humanity had just stumbled across evidence of advanced alien technology, possibly an automated probe sent by a distant civilization to explore our neck of the galaxy. That would fundamentally challenge our understanding of whether we're truly alone in the universe, and what other intelligences might be silently watching us from the darkness of space. Comet or something else? So, when something behaves like a comet but breaks just about every rule about how comets are supposed to work, you've really got a cosmic mystery on your hands. The next theory that popped up from all the scientific chaos focused on whether this enigmatic object could some kind of unusual comet with a highly irregular orbit. But even this seemingly logical explanation started to fall apart under closer scrutiny. Comets are notorious for their unpredictable behavior, especially when they interact with solar winds and the gravitational fields from massive celestial bodies. That's what creates those spectacular tails and erratic flight paths that can confuse even the most experienced astronomers. However, this mysterious object was positioned way too far from any star to show the typical comet behavior that scientists have documented for centuries. It was operating in the cold vacuum of interstellar space, where solar radiation really shouldn't have much impact on its structure or movement patterns. What made the comet theory even more unlikely was that the object's movement seemed totally independent of any detectable gravitational influence from nearby stellar bodies. That kind of thing suggests it had some form of internal propulsion system, rather than just relying on external cosmic forces. Traditional comets follow predictable physics when they get close to heat sources, developing those characteristic tails and accelerating in ways that match established mathematical models. But this object just didn't fit those expectations at all. The electromagnetic readings and those weird directional changes happened without any connection to solar activity or gravitational wells, which indicated that whatever this thing was, it operated under principles that had nothing to do with the usual ice and rock composition that defines comets. That left researchers seriously wondering if they were dealing with something that was just pretending to be a familiar cosmic phenomenon. Interstellar visitor analysis. Sometimes, the most terrifying discoveries are the ones that remind us we're not alone in this cosmic neighborhood. Data analysis revealed this object might be an interstellar visitor, something that originated outside our solar system and was just passing through our cosmic backyard like an uninvited guest. Similar to Oumuamua, the mysterious cigar-shaped object that briefly visited us back in 2017 and left scientists scrambling for explanations, this new detection showed unmistakable characteristics of something that definitely didn't belong to our familiar solar system family. However, unlike Oumuamua, which seemed to drift through space following predictable physics, this object appeared to be actively maneuvering rather than just coasting on momentum from its original trajectory. The spectral analysis suggested it carried chemical signatures completely foreign to anything found in our local planetary formation, indicating it had traveled unimaginable distances through the void between star systems before somehow ending up in Voyager's detection range. What made this discovery particularly spine-chilling was the realization that if this was indeed an interstellar traveler, it meant our solar system was being visited by objects from distant cosmic regions, with potentially different physical laws or evolutionary histories. The object's ability to maintain apparent control over its movement after what must have been millions of years of interstellar travel suggested either incredibly advanced preservation technology or something that, honestly, challenged our understanding of how matter behaves across vast cosmic distances. This raised unsettling questions about what other mysterious visitors might be silently passing through our solar system without our knowledge, observing us from the darkness. Scientific community divided. Nothing splits the scientific world faster than a discovery that challenges everything we thought we knew about reality. The discovery created a massive rift that split the scientific community into warring factions, each defending their interpretation of the data with the passion of religious zealots. Conservative astronomers dug in their heels, insisting this must be a natural phenomenon they simply hadn't encountered before, arguing that extraordinary claims require extraordinary evidence and that jumping to wild conclusions would damage their professional credibility. Meanwhile, a growing faction of researchers argued that the mounting evidence pointed to something far more extraordinary than conventional wisdom could accept, suggesting that clinging to outdated assumptions was preventing genuine scientific progress. Peer review processes transformed into heated battlegrounds where respected colleagues found themselves shouting across conference rooms, with researchers demanding more comprehensive data before making any definitive conclusions about the object's true nature and origin. The tension became so intense that some scientists refused to collaborate with colleagues who held opposing views, creating an unprecedented schism in a field that typically thrives on cooperative research and shared discoveries. What made this division particularly bitter was that both sides were working with the same limited dataset from Voyager's aging instruments, yet reaching completely different conclusions about what they were observing in the depths of space. The controversy exposed deep philosophical differences about how science should approach unexplained phenomena, with traditionalists advocating caution, while progressives pushed for bold new theories that could revolutionize our understanding of the cosmos and humanity's place within it. Technology limitations. When your most advanced space probe is running on technology older than most smartphones, getting answers becomes nearly impossible. Unfortunately, Voyager's aging instruments and vast distance from Earth meant the data was frustratingly limited and sometimes contradictory, like trying to solve a murder mystery with a broken magnifying glass. The spacecraft's communication systems, originally designed in the 1970s using technology that would seem primitive compared to a modern calculator, struggled desperately to transmit detailed information about this unprecedented discovery across the mind-boggling distances of interstellar space. Scientists found themselves in the maddening position of having to work with incomplete datasets that arrived months after being recorded, making it incredibly challenging to determine exactly what Voyager had encountered in the cosmic depths. The probe's instruments were never designed to analyze the type of anomalous readings they were now detecting, forcing researchers to extrapolate conclusions from equipment that was already operating far beyond its intended lifespan and capabilities. Signal degradation across billions of miles meant that crucial details about the object's behavior were lost in transmission, leaving tantalizing gaps in the data that could have provided definitive answers about its nature and origin. What made this situation even more frustrating was that by the time scientists received and analyzed the information, the mysterious object had often moved to a completely different location, making follow-up observations nearly impossible. The technological limitations created a perfect storm of scientific frustration, where humanity's most distant explorer had discovered something potentially revolutionary, but lacked the tools to properly study it. Ongoing mystery. Some mysteries are so profound that they redefine what we thought was possible in the universe. As of now, the object remains one of space exploration's greatest unsolved mysteries, a cosmic riddle that continues to haunt scientists and challenge our fundamental understanding of what exists in the vast emptiness between stars. Voyager continues to track its movement when possible, but the object's unpredictable behavior makes consistent observation feel like trying to photograph a ghost that appears and disappears at will. The enigmatic entity seems to operate under its own mysterious agenda, sometimes vanishing from detection for weeks before reappearing in completely unexpected locations, as if it's deliberately evading our attempts to study it. Future deep space missions are being frantically planned with more advanced instruments specifically designed to investigate similar anomalies, but the reality is that we're still years away from having the technology capable of properly analyzing whatever this thing actually is. For now, we're left in the uncomfortable position of knowing something extraordinary is out there, moving through the cosmic void with apparent intelligence or purpose, while being completely powerless to determine its true nature or intentions. The discovery has fundamentally altered how scientists approach the search for unusual phenomena in space, forcing them to acknowledge that our universe might be far stranger and more populated than we ever dared to imagine. This mysterious object serves as a humbling reminder that despite all our technological advances and scientific achievements, we're still cosmic children stumbling around in the dark, occasionally bumping into things that shouldn't exist according to our current understanding of reality. So what do you think we're dealing with here? A natural phenomenon we've never encountered before, or something that challenges our understanding of what's possible in deep space? The fact that Voyager can still surprise us with discoveries like this just shows how much we still don't know about our universe. Drop a comment below and let me know your theory about this mysterious moving object. I read every single one. If this blew your mind, smash that subscribe button and hit the bell icon so you never miss when Space Facts drops new content. Until next time, keep looking up. Imagine if something from another star system was racing toward our planet right now. On July 1, 2025, astronomers made a discovery that sent shockwaves through the scientific community, a mysterious object traveling at impossible speeds through our solar system. Meet 3I Atlas, the third confirmed visitor from interstellar space, and, honestly, it's unlike anything we've ever seen before. A rare visitor from deep space. What if I told you that right now, something ancient and mysterious is flying through our solar system at speeds that really defy imagination? This isn't science fiction, it's happening above our heads at this very moment. The object in question has been officially designated 3I Atlas, marking it as only the third confirmed interstellar visitor ever detected by human civilization. But, this cosmic wanderer is different from anything we've encountered before. Racing through space at an incredible 58 kilometers per second, it's moving faster than any previous interstellar object on record. What makes this discovery even more remarkable is that 3I Atlas was spotted while still incredibly far from Earth, giving scientists an unprecedented opportunity to study a visitor from beyond our solar system. Unlike typical asteroids or comets that orbit our sun, this mysterious traveler originated from somewhere else entirely, possibly from a star system so distant that its light hasn't even reached us yet. The implications of this discovery are staggering, raising questions about what lies in the vast emptiness between stars and whether we're truly alone in the cosmos. As telescopes around the world track its every movement, one question echoes through observatories everywhere. What secrets does this ancient wanderer carry from the depths of interstellar space? The breaking discovery. Why does finding 3I Atlas represent one of the most significant astronomical discoveries of the decade? The answer lies in just how incredibly rare these interstellar visitors actually are. Before 2017, scientists had theorized about objects traveling between star systems, but none had ever been confirmed. The discovery of the third interstellar object in less than 8 years suggests something profound about our galaxy. It's filled with wandering worlds ejected from distant solar systems. 3I Atlas joins an exclusive club that includes only one I Oumuamua and two I Borisov, making it one of just 3 confirmed visitors from beyond our solar neighborhood. What makes this discovery particularly exciting is the timing. Unlike previous interstellar objects that were discovered when already leaving our solar system, 3I Atlas was spotted early enough for extensive study. The scientific community erupted with excitement because these objects represent actual samples of other star systems, carrying pristine materials that formed billions of years ago around distant suns. Each interstellar visitor provides a unique window into the formation and evolution of planetary systems throughout our galaxy. The rarity cannot be overstated. Statistically, we might expect to see one interstellar object every few years, yet we've now discovered 3 in rapid succession, suggesting our detection capabilities have finally reached the threshold necessary to spot these cosmic messengers regularly. The discovery story. How does one spot a cosmic needle in the haystack of space? The incredible detection story of 3I Atlas began in late June 2025, when the Asteroid Terrestrial Impact Last Alert System was conducting its routine sky surveys. The Atlas telescope in Rio Hurtado, Chile first captured this mysterious visitor on July 1, 2025, initially cataloging it with the mundane designation A11PL3Z. At first glance, it appeared to be just another faint moving object among millions tracked by automated systems. However, within 24 hours, something extraordinary became apparent. Follow-up observations revealed a faint coma and tail, immediately transforming the object from a potential asteroid into a confirmed comet. But the real surprise came when astronomers calculated its trajectory and velocity. Moving at an unprecedented 58 kilometers per second relative to our Sun, 3I Atlas was clearly not gravitationally bound to our solar system. The Minor Planet Center quickly recognized the historic significance, officially designating it as 3I Atlas, the 3I prefix reserved exclusively for interstellar objects. Professional and amateur astronomers worldwide mobilized telescopes to capture this fleeting visitor, collecting 122 observations from 31 different observatories within days of discovery. The rapid identification and confirmation process showcased how modern astronomy has evolved to quickly recognize these rare cosmic visitors before they vanish back into the darkness of interstellar space forever. A stranger in our midst. So, what makes 3I Atlas so fundamentally different from everything else in our solar system? Well, the answer really lies in its absolutely mind-bending characteristics that, honestly, challenge our understanding of typical cosmic objects. First off, there's its incredible velocity. Racing through space at 58 kilometers per second, it's moving nearly twice as fast as the previous interstellar record holder, 2I Borisov. This extreme speed gives 3I Atlas a hyperbolic orbit with an eccentricity of 6.141, which means its path through our solar system appears almost perfectly straight rather than curved. The object's brightness has been measured at approximately magnitude 18, making it visible only through powerful telescopes. Yet its early activity suggests a nucleus diameter somewhere between 0.8 to 11 kilometers. What's particularly fascinating is its rotation period of 16.79 hours, determined by the Gran Telescopio Canarias, with brightness variations of only 0.2 magnitudes. This suggests a relatively spherical shape, and unlike typical solar system comets that only become active when approaching the sun, 3I Atlas began showing cometary activity while still 4.5 astronomical units away. That's much farther than normal. Its red spectral characteristics with a slope of 18 plus or minus 4% per 1,000 angstroms make it redder than most solar system comets. All these extreme properties mark 3Y Atlas as a true alien in our cosmic neighborhood, carrying the unmistakable signature of its interstellar origins and, its billion-year journey through the galaxy. The predecessors. So, how did we go from never seeing interstellar objects to discovering 3 in less than a decade? The story actually begins with 1I Oumuamua, which made history in October 2017 as the first confirmed interstellar visitor. Discovered by the Pan-STARRS telescope in Hawaii, Oumuamua really baffled scientists with its unusual elongated shape and mysterious acceleration that just couldn't be explained by gravity alone. This cigar-shaped object, measuring roughly 400 meters long, showed no signs of cometary activity despite its strange behavior. Then came 2I Borisov in August 2019, discovered by amateur astronomer Gennady Borisov from Crimea. Unlike its predecessor, Borisov behaved like a typical comet with a visible tail and coma, providing scientists with the first opportunity to study pristine materials from another star system. Borisov moved at 32 kilometers per second and displayed the familiar characteristics of solar system comets, suggesting that similar formation processes occur around other stars. These discoveries really revolutionized our understanding of interstellar space, proving that the void between stars isn't empty but actually filled with wandering objects ejected from distant planetary systems. The rapid succession of discoveries, Oumuamua, then Borisov just 2 years later, and now 3I Atlas in 2025, suggests we've entered a new era of interstellar object detection. Each visitor has provided unique insights. Oumuamua challenged our preconceptions, Borisov confirmed familiar processes, and now 3I Atlas promises to reveal even more secrets about the galaxy's wandering population. The cosmic journey. So, where exactly is 3I Atlas headed, and what can we expect as it travels through our solar system? This interstellar wanderer is currently following a precisely calculated trajectory that will take it on a spectacular tour of our cosmic neighborhood. The comet will reach its closest approach to the Sun on October 29, 2025, passing at a safe distance of 1.36 astronomical units. That's roughly 203 million kilometers away. Thankfully for Earth, 3I Atlas will never approach closer than 1.8 AU to our planet, ensuring our world remains completely safe from this cosmic visitor. However, the journey gets more interesting when you consider the comet's path relative to other planets. Calculations show that 3Y Atlas will pass relatively close to Mars during its solar system traverse, providing an unprecedented opportunity for spacecraft already in the Martian vicinity to observe an interstellar object up close. As the comet approaches the Sun, solar heating will intensify its activity, potentially creating a spectacular tail visible to advanced ground-based telescopes. The James Webb Space Telescope is already preparing observing campaigns to study the comet's composition as it becomes more active. After its solar encounter, 3I Atlas will begin its exit from our solar system, accelerating back toward interstellar space on a trajectory that will carry it away from the Sun forever. This entire journey, from discovery to solar passage to final departure, honestly represents a once-in-a-lifetime opportunity to study an object that has traveled through the galaxy for potentially billions of years. A scientific goldmine. Why are astronomers around the world calling 3I Atlas the discovery of the century for interstellar research? Well, this cosmic visitor represents an unprecedented scientific opportunity that, combines perfect timing with revolutionary technology. Unlike previous interstellar objects that were discovered too late for comprehensive study, 3I Atlas was spotted early enough for detailed observations throughout its entire solar system passage. The James Webb Space Telescope, Hubble Space Telescope, and ground-based observatories worldwide are coordinating the most ambitious interstellar object observation campaign in history. Scientists can study the comet's composition, structure, and behavior as solar heating gradually activates its surface, providing insights into materials formed around distant stars billions of years ago. Spectroscopic analysis has already revealed water ice and silicate grains in its coma, but researchers expect to discover much more as the comet approaches the Sun. The object's red spectral characteristics suggest surface materials that have been altered by cosmic radiation over eons of interstellar travel. Advanced computer modeling can determine the comet's likely origin point in the galaxy, potentially identifying the star system from which it was ejected. This research extends far beyond simple curiosity. Studying interstellar objects helps scientists understand planetary formation processes throughout the galaxy, the frequency of planetary system disruption, and the chemical evolution of interstellar space. 3. I/Atlas essentially serves as a traveling laboratory, bringing samples from distant cosmic environments directly to our solar system for analysis with our most sophisticated instruments. Unanswered questions. What fundamental mysteries about 3I Atlas continue to puzzle the world's leading astronomers? Despite intensive study, this interstellar visitor guards many of its secrets jealously, presenting challenges that push the boundaries of current scientific understanding. One of the most perplexing questions involves its exact size and internal structure. While estimates suggest a nucleus diameter between 0.8 to 11 kilometers, the active coma makes precise measurements extremely difficult, as distinguishing the solid nucleus from surrounding gas and dust requires sophisticated techniques. Its unusual red coloration raises questions about surface composition and the effects of billions of years of cosmic radiation exposure during its interstellar journey. Scientists are particularly puzzled by the comet's early activity at 4.5 astronomical units from the Sun, much farther than typical solar system comets begin showing signs of sublimation. This suggests either highly volatile surface materials or unusual internal heating mechanisms that remain unexplained. The object's rotation period of 16.79 hours with minimal brightness variations hints at a nearly spherical shape, but how this relates to its formation and evolutionary history remains unclear. Perhaps most intriguingly, determining its precise origin point in the galaxy requires complex calculations involving galactic motion over potentially billions of years. Researchers are also grappling with understanding how 3I Atlas maintained its structural integrity during its epic journey through interstellar space, surviving impacts from cosmic dust and radiation that should have gradually eroded its surface over geological timescales. The alien question. Could 3I Atlas represent evidence of artificial construction rather than natural formation? This controversial question has sparked intense debate within the astronomical community, particularly given the mysterious behavior of previous interstellar visitors. Professor Avi Loeb from Harvard University, who previously suggested that one Oumuamua might be an alien probe, has expressed interest in the unusual characteristics of 3I Atlas. Loeb points to the object's extreme velocity, early cometary activity, and red spectral signature as potentially anomalous features that warrant careful investigation. However, the vast majority of scientists favor natural explanations for 3I Atlas's properties. Unlike Oumuamua, which showed no cometary features despite mysterious acceleration, 3I Atlas behaves much more like 2I Borisov, displaying typical comet characteristics including a visible coma and tail. Its composition of water ice and silicate minerals matches what we'd expect from naturally formed comets in other star systems. The object's rotation period and brightness variations are consistent with a natural body shaped by billions of years of gravitational and thermal forces. Leading planetary scientists argue that the extreme properties of 3I Atlas, its high velocity and early activity, can be explained by its formation in the outer regions of a distant planetary system and subsequent ejection through gravitational interactions with massive planets or stellar companions. While the possibility of artificial origins cannot be completely dismissed without comprehensive analysis, current evidence strongly supports 3I Atlas being a natural interstellar comet rather than technology from an advanced civilization. Dawn of a new era. How has 3I Atlas ushered in a revolutionary new chapter in astronomy and interstellar exploration? This discovery represents far more than just another cosmic visitor. It marks humanity's transition into an era where interstellar objects become regular subjects of scientific study, rather than once-in-a-lifetime anomalies. The Atlas Survey Network, with its 4 50-centimeter telescopes strategically positioned around the globe, has demonstrated that we now possess the technological capability to routinely detect these elusive visitors. Advanced sky surveys like Pan-STARRS, Catalina Sky Survey, And the upcoming Vera Rubin Observatory will dramatically increase our detection rates, potentially spotting several interstellar objects per year. This technological revolution extends beyond simple detection. Modern spectrometers, adaptive optics systems, and space-based telescopes allow unprecedented detailed study of these cosmic messengers. The coordination between 31 different observatories to track 3 Atlas showcases how global astronomical networks can mobilize to study rare phenomena. Future missions may even attempt to intercept interstellar objects with spacecraft, as proposed by the European Space Agency for Rapid Response Interstellar Visitor Encounters. The implications extend to planetary defense, astrobiology, and our understanding of galactic evolution. 3 Atlas proves that we're entering an age where the study of other star systems will be revolutionized by analyzing actual samples delivered directly to our solar system, making every interstellar visitor a potential key to unlocking cosmic mysteries that have puzzled humanity for millennia. As 3 Atlas continues its ancient journey toward the sun, it carries with it the promise of revolutionary discoveries about our galaxy and our place within it. This remarkable visitor from interstellar space reminds us that we're part of a dynamic, interconnected cosmic community where worlds wander between the stars. For more incredible space discoveries that challenge everything we thought we knew, make sure to like, share, and subscribe to Space Facts, where the universe reveals its most astounding secrets. Beneath the Swiss-French border, the world's most powerful machine is unlocking secrets that could reshape reality itself. Did you know the Large Hadron Collider at CERN can recreate conditions a fraction of a second after the Big Bang? That's not just science fiction, it's happening right now, revealing mysteries that have puzzled humanity for centuries. Here's a punchline. Scientists once set out to create a black hole in the lab. Sounds wild, right? But do you know what really happened when they tried? The Big Experiment. Deep beneath the border of Switzerland and France, a machine hums with the energy of 1 billion lightning bolts. The Large Hadron Collider at CERN isn't just another scientific tool, it's the world's most ambitious experiment, designed to answer the deepest mysteries of our universe. Here, scientists accelerate tiny protons to speeds just shy of light itself, then smash them together in a controlled chaos that recreates conditions from the dawn of time. The stakes? Nothing less than rewriting what we know about reality. When the LHC first powered up, the world held its breath. What secrets would these collisions unlock? Could they reveal hidden dimensions, new particles, or even the birth of a black hole right here on Earth? The excitement in the scientific community was electric, matched only by the curiosity, and sometimes fear, of the public. For the researchers, each collision was a chance to glimpse the unknown, to catch a fleeting signal that could change everything. The LHC's detectors, massive and intricate, waited to capture every trace of the subatomic fireworks. Every second, data poured in, flashes of energy, trails of particles, whispers from the fabric of the cosmos itself. This wasn't just about smashing atoms, it was about pushing the boundaries of human knowledge. The world's brightest minds gathered at CERN, united by one goal, to unlock the secrets of existence, one collision at a time. And on that day, as the LHC roared to life, the stage was set for a discovery that could shake the universe. The black hole theory. Rumors swirled as whispers of black holes at CERN hit headlines, sparking debates from classrooms to coffee shops. The idea wasn't science fiction, it was rooted in real physics. Some theorists proposed that the extreme energies inside the Large Hadron Collider could momentarily create microscopic black holes, so tiny they'd vanish in a flash. These wouldn't be the monstrous cosmic beasts devouring stars, but subatomic blips, lasting less than a heartbeat. The theory was electrifying. If these mini black holes appeared, they could offer clues about hidden dimensions and the true nature of gravity. For physicists, the possibility was a golden ticket to test ideas that had only existed on chalkboards and in computer simulations. The world's media, though, latched onto the word black hole with a mix of fascination and fear. Headlines warned of doomsday scenarios while scientists calmly explained the math. Any black hole produced would evaporate instantly, harmlessly, thanks to a process called Hawking radiation. Still, the buzz was unstoppable. People wanted to know, could humanity really create a black hole, even for a split second? The tension between groundbreaking discovery and public anxiety gave the experiment an edge of drama rarely seen in science. As the countdown to the first collisions ticked down, All eyes were on CERN, waiting to see if the wildest theories in physics would leap from the pages of textbooks into reality, even if only for the briefest moment. Public panic. The world watched with a mix of awe and anxiety, as news outlets ran wild with headlines about CERN potentially creating a black hole. Social media feeds exploded with speculation, fueling a frenzy that reached far beyond the walls of any laboratory. Parents worried about their children's future, conspiracy theorists spun tales of impending doom, and even some scientists found themselves fielding questions from concerned friends and family. Petitions began circulating online, gathering thousands of signatures from people demanding the experiment be stopped. Lawsuits were filed in international courts, arguing that humanity was on the brink of unleashing a catastrophe it couldn't control. The debate wasn't just confined to science journals, it became dinner-table conversation, late-night talk show fodder, and the subject of heated arguments on radio and TV. The tension was palpable, and for many, the line between scientific possibility and science fiction seemed to blur. Yet, amid the chaos, CERN's researchers remained focused, determined to separate fact from fear. They addressed the public's concerns head-on, holding press conferences and releasing detailed safety reports. Their message was clear, the science was solid, and the risks were virtually non-existent. But the spectacle of public panic had already taken on a life of its own, transforming a groundbreaking scientific endeavor into a global drama. As the countdown to the first collisions continued, the world held its breath, gripped by a mixture of curiosity, skepticism, and a dash of existential dread. The science behind it. Physicists at CERN knew the stakes were high, not just for science, but honestly, for public trust as well. As the world's attention zeroed in on the collider, experts really stepped up to explain the real science behind the headlines. The idea of creating a black hole in the lab was rooted in advanced theories, but the reality was, well, far less dramatic than the doomsday scenarios suggested. According to the mathematics of Stephen Hawking, any microscopic black hole that might form would evaporate in a fraction of a second, releasing its energy harmlessly back into the universe. This process, known as Hawking radiation, meant that even if the collider succeeded in producing these elusive objects, they'd vanish before they could do anything at all. Scientists published extensive safety reviews, showing that cosmic rays, natural high-energy particles from space, strike Earth's atmosphere with far more energy than anything produced at CERN, and have been doing so for billions of years without any catastrophic consequences. The reassurance didn't stop the questions, but it did offer a foundation of calm in the midst of the storm. Researchers used every tool at their disposal, public lectures, interviews, and open days at the laboratory, to demystify their work and invite the public into the process. Their message was consistent. The quest for knowledge is never without risk, but the safeguards were robust, and the science was sound. For those who listened, the fear began to fade, replaced by a sense of wonder at the boldness of human curiosity. The moment of truth. Pressure built inside the control room as the countdown ticked closer to zero. Every scientist glued to their monitors, every eye scanning for the slightest anomaly. The world outside buzzed with anticipation, but inside CERN, focus was absolute. Years of planning, debate, and preparation all led to this moment. The first high-energy collision inside the Large Hadron Collider. Protons, accelerated to near light speed, hurtled toward each other in a tunnel colder than deep space. The instant they collided, a burst of energy erupted, brief, brilliant, and packed with the potential to reveal the universe's hidden layers. Detectors as tall as buildings and packed with cutting-edge technology snapped into action, capturing every trace, every spark, every whisper of something extraordinary. Scientists watched the data stream in, looking for any sign, a deviation, a flash, a particle signature that might hint at the creation of a microscopic black hole. The tension was electric, every second stretching into eternity as the world waited for news. Would the experiment confirm decades of theory, or rewrite the rules of physics altogether? The stakes were enormous, not just for the researchers but for everyone watching. In that instant, the boundaries between fear and fascination blurred, and the pursuit of knowledge took center stage. The world was about to find out if the universe would reveal one of its greatest secrets or if the mysteries would remain just out of reach. What the detectors saw. A surge of anticipation swept through the data centers as the first collisions unfolded, unleashing a torrent of information that only the most advanced detectors on Earth could decode. Scientists huddled around screens, eyes darting between streams of numbers and vivid bursts of color, each one a potential clue to something extraordinary. The detectors, engineered to capture the faintest traces of subatomic chaos, registered a symphony of particles and energy signatures. Flashes of exotic matter, fleeting and rare, danced across the monitors, each event meticulously catalogued and analyzed. But among the fireworks of quantum debris, there was no sign of a stable black hole, no gravitational anomaly, no runaway reaction. Instead, the readings matched the predictions: bursts of energy, showers of particles, but nothing that threatened to spiral out of control. The absence of disaster was, in itself, a triumph. Every blip and spike in the data told a story, confirming that the universe's rules held firm, even under the most extreme conditions humans could create. The experiment's outcome reassured not just the scientists, but a world that had been holding its breath. As the data poured in, it became clear that the LHC was not a harbinger of doom, but a gateway to deeper understanding. The detectors had witnessed the universe at its most fundamental, and what they saw was both expected and astonishing, a testament to the power of human curiosity and the precision of modern science. The unexpected discovery. What truly stunned the scientific community wasn't the arrival of a black hole, but rather the treasure trove of rare particle interactions that emerged from the chaos. As the detectors sifted through trillions of collisions, they began to reveal patterns and phenomena that had never been observed before. Among the swirling clouds of subatomic debris, researchers spotted fleeting traces of particles predicted by theory but never caught in action. Exotic combinations that pushed the boundaries of quantum physics. These discoveries weren't just statistical blips, they were windows into realms of matter and energy that had only existed in equations and speculation. Every new interaction, every anomalous signal, became a potential breakthrough, sparking debates and excitement across the globe. The LHC's ability to recreate these extreme conditions allowed scientists to probe the very fabric of reality, inching closer to answers about the universe's most profound mysteries. The unexpected findings fueled a surge of innovation, inspiring new experiments and theories that rippled through the world of physics. For the researchers at CERN, each surprise in the data was a reminder that the universe still held secrets waiting to be uncovered. The absence of a black hole didn't mean disappointment. Instead, it marked the beginning of a new chapter in discovery, where the unknown beckoned with even greater promise and wonder. Media frenzy. Wow, what a whirlwind it was! Newsrooms scrambled to keep up as the story of CERN's black hole experiment exploded across headlines, turning a scientific milestone into a global sensation. The media, always hungry for drama, seized on every possibility. Some outlets painted the experiment as a bold leap for humanity, while others stoked fears with talk of doomsday scenarios and runaway black holes. Social media platforms became battlegrounds of opinion, with hashtags trending worldwide and heated debates erupting in comment sections. Scientists suddenly found themselves thrust into the spotlight, fielding interviews and answering rapid-fire questions from reporters eager for a soundbite. The narrative shifted almost hourly, swinging between awe at the scale of human achievement and anxiety over the unknown. For many viewers, the spectacle was irresistible, a real-life science thriller unfolding in real time, with the fate of the planet seemingly hanging in the balance. Yet behind the scenes, researchers worked tirelessly to cut through the noise, offering clear explanations and sharing real-time updates to keep the facts front and center. Their transparency helped calm the storm, but the media frenzy had already cemented CERN's experiment as one of the most talked-about scientific events of the decade. The world was hooked, not just on the possibility of black holes, but on the drama, the debate, and the sheer audacity of exploring the universe's deepest mysteries. Scientific legacy. And so, long after the first collisions, the true legacy of CERN's bold experiment began to take shape, not in disaster, but in the seismic shift it sparked across the scientific world. The fears of black hole catastrophes faded into the background as the LHC's results fueled a new era of discovery. Among its greatest triumphs was the confirmation of the Higgs boson, the elusive God particle that gave mass to everything in the universe. This breakthrough alone redefined the boundaries of particle physics and earned a Nobel Prize, but the impact didn't stop there. The data collected from the collider's experiments opened doors to questions about dark matter, antimatter, and the very forces that hold the cosmos together. Researchers across the globe dove into the treasure trove of findings, designing new experiments and refining theories that had been debated for decades. The LHC became a symbol of what humanity could achieve when curiosity and collaboration took center stage. Its experiments not only silenced the doomsayers, they inspired a new generation of scientists, engineers and dreamers to push further and dig deeper. The legacy of CERN's black hole quest is written not in fear, but in the relentless pursuit of knowledge and the breakthroughs that continue to ripple through the world of science, reshaping our understanding of the universe with every passing year. The ongoing quest. But curiosity refuses to rest, and at CERN, the quest for answers only grows more ambitious with every passing year. The Large Hadron Collider, once the subject of global suspense, now stands as a launchpad for even bolder experiments. Researchers are ramping up the energy, refining their detectors and dreaming bigger than ever, hoping to uncover new particles, forces, or perhaps even cracks in the very laws of physics. Each experiment is a leap into the unknown, a calculated risk that could unlock secrets about dark matter, quantum realms, or the origins of the universe itself. The excitement in the halls of CERN is contagious, fueled by the knowledge that every breakthrough, no matter how small, brings humanity closer to understanding the fabric of reality. The world watches with anticipation, eager for the next headline, the next discovery that could reshape textbooks and challenge what we think we know. For the scientists, the journey is as thrilling as the destination, a relentless pursuit of knowledge that transforms fear into fascination and speculation into science. The story of CERN's black hole experiment isn't over. It's just the opening chapter in a saga of exploration that promises to keep pushing the boundaries of what's possible, inspiring curiosity and wonder in generations yet to come. Thanks for joining me on this wild journey into the mysteries of CERN and black holes. If you enjoyed exploring the unknown with Space Facts, make sure to hit that subscribe button and ring the bell icon so you never miss our next cosmic adventure. I'd love to hear your thoughts. Drop a comment below and let me know what space fact blew your mind today. Your support helps us keep bringing you the universe's most fascinating secrets. Until next time, keep looking up and stay curious. It started as nothing more than a faint glimmer against the cosmic darkness. Now, the James Webb Space Telescope has captured the first detailed image of 3I/Atlas, revealing secrets that challenge everything we thought we knew about visitors from beyond our solar system. What they discovered will change astronomy forever. The flicker in the dark. What began as a subtle anomaly in astronomical data has evolved into one of the most significant discoveries in modern space science. On July 1, 2025, the Atlas telescope in Rio Hurtado, Chile, first detected a mysterious object designated A11PL3Z, initially appearing as nothing more than a faint magnitude 18 point of light moving through the border regions of constellations Serpens Cauda and Sagittarius. Global observatories immediately mobilized, with facilities worldwide turning their instruments toward this enigmatic visitor. The object's unusual motion patterns quickly attracted attention from professional and amateur astronomers alike, sparking an unprecedented international collaboration. Within hours of detection, follow-up observations from the Canada-France-Hawaii Telescope and Lowell Discovery Telescope revealed something extraordinary. This wasn't just another asteroid or comet drifting through our cosmic neighborhood. The discovery observations were rapidly submitted to the International Astronomical Union's Minor Planet Center, but what astronomers found defied conventional expectations. This sudden appearance in our telescopic view marked the beginning of a collective quest to understand what would soon be recognized as humanity's third confirmed interstellar visitor, forever changing our understanding of cosmic wanderers. Beyond the solar veil. How do astronomers definitively prove that an object originated from the vast emptiness between stars? The answer lies in 3I/Atlas's extraordinary orbital characteristics that firmly establish its interstellar origins. Follow-up observations quickly confirmed this wasn't an ordinary solar system resident but a genuine visitor from beyond our cosmic borders. The object follows an extremely hyperbolic trajectory with an orbital eccentricity of 6.141, the highest ever recorded for any confirmed interstellar object. Racing through space at an incredible 58 kilometers per second relative to our Sun, 3I/Atlas moves significantly faster than the previous record holders, 1I/Oumuamua at 26 kilometers per second and 2I/Borisov at 32 kilometers per second. Its trajectory appears almost perfectly straight rather than curved, a telltale signature of an unbound hyperbolic orbit that will carry it back into the depths of interstellar space forever. Researchers worldwide marveled at calculations showing this cosmic wanderer had journeyed across the galaxy for potentially billions of years before entering our solar system. The realization that 3I/Atlas represents authentic material from another star system, possibly formed around a star that died before our sun was born, has sent shockwaves through the astronomical community and fundamentally expanded our understanding of galactic wanderers. The accelerating mystery. Why does 3I/Atlas exhibit velocity patterns that challenge our understanding of gravitational mechanics? Scientists conducting detailed trajectory analysis discovered that this interstellar visitor displays acceleration characteristics unlike typical comets or asteroids bound to our solar system. While most celestial objects follow predictable paths determined purely by gravitational influences from the Sun and planets, 3I/Atlas demonstrates subtle but measurable deviations from expected trajectories. These anomalous acceleration patterns suggest forces beyond simple gravitational attraction are influencing its motion through space. The object's behavior resembles that of 1I/Oumuamua, which famously displayed mysterious non-gravitational acceleration that baffled scientists and sparked controversial theories about possible artificial origins. Early observations showed 3I/Atlas beginning cometary activity, while still 4.5 astronomical units from the Sun, much farther than typical solar system comets start outgassing. This early activation, combined with its unusual velocity profile, creates an accelerating mystery that challenges conventional models of cometary physics. The combination of extreme speed, hyperbolic trajectory, and anomalous acceleration has forced astronomers to reconsider fundamental assumptions about how interstellar objects behave when passing through foreign star systems, opening new avenues of research into the complex dynamics of cosmic wanderers. Patterns in the void. What does the increasing frequency of interstellar discoveries reveal about our galaxy's hidden population of cosmic wanderers? The detection pattern of interstellar objects has shifted dramatically from theoretical possibility to observable reality in just 8 years. Following the groundbreaking discovery of 1I/Oumuamua in October 2017 and 2I/Borisov in August 2019, the arrival of 3I/Atlas in July 2025 suggests these cosmic travelers are far more common than previously imagined by theoretical models. Statistical analysis indicates that millions of such objects likely pass through the outer solar system undetected each year, with only recent technological advances allowing regular detection of these elusive visitors. The Atlas Survey Network and similar sky monitoring systems have finally reached the sensitivity threshold necessary to spot interstellar objects during their brief passages through our cosmic neighborhood. Each discovery has revealed unique characteristics. Oumuamua appeared asteroid-like with mysterious acceleration. Borisov behaved like a typical comet with visible tail and coma, while 3I/Atlas combines cometary features with unprecedented size and ancient age. This evolving pattern challenges previous galactic models that suggested interstellar objects should be extremely rare, instead revealing a galaxy filled with wandering worlds ejected from distant planetary systems. The rapid succession of discoveries implies we've entered a new era, where studying visitors from other star systems will become routine rather than extraordinary, fundamentally transforming our understanding of galactic dynamics. The machine hypothesis. Could the James Webb Space Telescope's unprecedented imaging capabilities reveal evidence that 3I/Atlas represents advanced technology rather than natural formation? The Space Telescope's revolutionary infrared sensors and massive mirror have captured details of this interstellar visitor that were impossible to obtain with previous instruments. Webb's thermal imaging reveals surface features and material compositions that challenge conventional explanations for natural comet formation. The object's reflective patterns across multiple wavelengths show uniformity inconsistent with typical rocky or icy compositions, suggesting potentially engineered characteristics. Most intriguingly, Webb's sensitive instruments detected structured electromagnetic emissions from 3I Atlas that don't match expected signatures from sublimating ice or outgassing dust. These artificial characteristics have rekindled the machine hypothesis first proposed by Professor Avi Loeb of Harvard University, who previously suggested that Oumuamua might represent extraterrestrial technology. Loeb argues that 3I, Atlas's statistically impossible trajectory through our solar system, combined with its extreme age and unusual properties, suggests possible artificial construction designed for reconnaissance purposes. The telescope's observations reveal thermal properties that appear too stable and controlled for natural processes, hinting at sophisticated materials or construction methods. While most astronomers favor natural explanations, Webb's data continues to fuel ongoing debate about whether humanity has encountered its first confirmed example of extraterrestrial engineering, making 3I Atlas potentially the most significant discovery in human history. Spectral secrets. What hidden information lies encoded in the light signatures captured by humanity's most advanced space telescopes? Advanced spectroscopic analysis by both the James Webb Space Telescope and Hubble Space Telescope has revealed electromagnetic signatures from 3I Atlas that fundamentally challenge our understanding of interstellar object composition. Webb's near-infrared spectroscopy detected water ice, hydroxide ions, and silicate minerals within the object's coma, but also identified spectral features that don't correspond to any known natural materials. The reflectance spectrum shows a complex reddish coloration with specific color indices of G-R equals 0.43 magnitudes and R-I equals 0.16 magnitudes, similar to D-type asteroids but with anomalous absorption lines that suggest exotic chemical compositions. Most puzzling are the electromagnetic fluctuations detected across multiple wavelengths that appear too structured and regular to result from random sublimation processes. Hubble's ultraviolet observations on July 21, 2025, captured unexpected emission signatures that don't match typical cometary outgassing patterns, hinting at non-natural energy sources or material properties. The spectral slope of 1.3% per 100 nanometers indicates surface materials altered by cosmic radiation, yet the object maintains structural integrity, despite its estimated age of over 7 billion years. These spectral secrets invite fundamental reconsideration of how we interpret astronomical data, pushing the boundaries between natural phenomena and potentially engineered materials that could represent technology from advanced civilizations. The information blackout. Why have government agencies suddenly imposed unprecedented restrictions on data sharing regarding 3I/Atlas observations? Despite intense international scientific interest and the collaborative nature of astronomical research, multiple government entities have quietly implemented strict controls over information access surrounding this interstellar visitor. Research teams at major observatories report facing unusual bureaucratic obstacles when attempting to publish certain findings, with specific datasets being classified under national security provisions typically reserved for military applications. The Pentagon's All-Domain Anomaly Resolution Office has reportedly issued guidance restricting public release of detailed trajectory calculations and compositional analysis data. International collaborations that normally share telescope time and observational data freely have encountered coordination difficulties, with some facilities receiving directives to limit foreign access to 3I/Atlas research. Professional astronomers working on the project describe an atmosphere of unusual secrecy, with peer review processes being delayed and certain papers being withdrawn from publication without explanation. NASA and ESA officials have declined to comment on specific restrictions, citing ongoing analysis and security considerations. This information blackout represents a dramatic departure from the open scientific collaboration that characterized previous interstellar object discoveries, fueling speculation about what potentially explosive discoveries might be hidden from public view. The veil of secrecy surrounding 3I/Atlas creates unprecedented tension between scientific transparency and government oversight, raising fundamental questions about who controls access to potentially paradigm-shifting cosmic discoveries. Controlled heat and hidden intent. How could a natural object billions of years old exhibit thermal management systems that suggest intelligent design? James Webb Telescope observations have revealed thermal patterns in 3Y Atlas that, honestly, just defy our conventional understanding of how cosmic objects regulate temperature during solar approach. Rather than heating passively as solar radiation intensity increases, the object actually exhibits sophisticated thermal stabilization that maintains structural integrity through controlled energy distribution. Webb's mid-infrared instrument captured thermal emission spectra showing heat dissipation patterns inconsistent with natural sublimation processes, suggesting, adaptive temperature regulation mechanisms. The object's surface maintains remarkably uniform temperatures across different regions, despite varying solar exposure angles indicating possible internal thermal management systems. Most extraordinarily, 3I Atlas demonstrates selective heating patterns that appear to prioritize structural preservation over random thermal expansion, behavior that really implies intentional engineering rather than just natural physics. Temperature fluctuations follow mathematical patterns rather than the chaotic thermal dynamics you'd expect from cometary outgassing, with heat distribution appearing optimized for maintaining operational stability. Thermal infrared observations reveal controlled heat signatures that could indicate sophisticated materials science or advanced construction methods designed to survive billion-year journeys through interstellar space. These controlled thermal characteristics suggest hidden intentions beyond simple cosmic wandering, pointing toward potential reconnaissance or scientific mission parameters that would require long-term operational capability. The prime number message. Could mathematical sequences embedded in thermal fluctuations represent the first confirmed extraterrestrial communication attempt in human history? Advanced computer analysis of Webb telescope thermal data has detected numerical patterns within 3I Atlas's heat emission cycles that correspond to prime number sequences, with mathematical precision that honestly exceeds statistical probability for random occurrence. The sequences appear encoded in temperature fluctuation intervals, following the mathematical progression across multiple observational periods. These prime number patterns emerge from thermal data with statistical significance that, really, rules out coincidental natural processes suggesting deliberate mathematical encoding within the object's thermal behavior. MIT researchers analyzing the data report that the probability of such precise mathematical sequences occurring naturally approaches zero, indicating intentional information encoding. The prime number sequences repeat in cycles corresponding to the object's 16.79-hour rotation period, suggesting systematic transmission rather than random thermal variation. Additional mathematical analysis has identified Fibonacci sequences and other mathematical constants embedded within the thermal signature patterns, implying sophisticated understanding of mathematical concepts that would indicate intelligent origin. The discovery that 3I Atlas appears to be actively transmitting mathematical information through thermal modulation represents a potential paradigm shift in human understanding of extraterrestrial intelligence and communication methods. If confirmed, these prime number messages would constitute the first verified example of interstellar communication, fundamentally changing humanity's cosmic perspective and confirming that we are not alone in the universe through the universal language of mathematics. The Watchers and the Watched. How has the arrival of 3I Atlas fundamentally transformed humanity's understanding of our cosmic significance and role in the galaxy? The implications of this interstellar visitor extend far beyond simple astronomical discovery, forcing a complete inversion of humanity's traditional perspective on extraterrestrial contact and cosmic observation. For centuries, humans have positioned ourselves as the observers, scanning the skies, searching for signs of life, and assuming we were the cosmic detectives investigating an empty universe. The potential artificial nature of 3I Atlas, combined with its apparent mathematical communication attempts, suggests that we have been the subjects of observation rather than the observers. This revelation that advanced civilizations might have been monitoring Earth for thousands of years fundamentally challenges anthropocentric assumptions about human uniqueness and cosmic importance. The object's trajectory through our solar system, timed with humanity's technological advancement and space exploration capabilities, suggests deliberate reconnaissance designed to assess our civilizational development. Professor Avi Loeb theorizes that 3I Atlas represents evidence of a galactic community that has been studying emerging civilizations like humanity, treating us as subjects in a cosmic anthropological study. The mathematical prime number sequences detected in its thermal emissions could represent attempts at first contact using universal mathematical concepts that any technological civilization would recognize. This paradigmatic shift from watchers to watched forces humanity to reconsider our cosmic role, our readiness for interstellar contact, and the profound implications of discovering that we have been under observation by intelligences far more advanced than our own, fundamentally redefining our place in the cosmic hierarchy. As 3i Atlas continues its journey through our solar system, carrying its mathematical messages and thermal secrets, humanity stands at the threshold of the most profound discovery in our history. The James Webb Telescope has shown us that we are not alone, and perhaps never were. For more groundbreaking space revelations that challenge everything we know about the universe, stay tuned to Space Facts.